Today we're going to continue discussing functions and important features of functions, focusing on evaluating today. So just as a quick review, remember, f of x is what we would call function notation. Okay, what is function notation? Well, remember, it really just stands for y, right? It's the output value, except that it gives a specific name to our function, f, and tells you the variable that is used in the function, x. So now anytime we plug in a value for this x, we are being asked to plug in the value into the formula that is given for the question. So let's see what it asks. Let g of x equal to the absolute value of negative 2x minus 3 plus 1. Find the following. So the first thing they want to do is have us find g of negative 4. G of negative 4 simply means I'm going to plug in a negative 4 any place that I see x. Okay? And then I evaluate step by step using order of operations, right? So inside my absolute value, I'm going to multiply negative 2 times negative 4, right? Keep simplifying that absolute value to get absolute value of 5. The absolute value of a positive number is still the positive number. So I end up with 5 plus 1. So my final answer is 6. So g of negative 4 is equal to 6. Okay, let's continue. What if they ask me for g of 8? Well, we do the same thing. Negative 2 times 8 minus 3 plus 1. I would get a negative 16 minus 3, which would be minus 19 plus 1. Now remember, if I have a negative inside the absolute value, that means that I'm going to take it out as a positive. So I get 19 plus 1. So this is 20. So g of 8 is equal to 20. When I plug 8 in, I get an output of 20. And last but not least, g of negative 1, we do the same thing. Plug in negative 1 anywhere I see. This becomes 2 minus 3 plus 1 minus 1 plus 1. This negative value comes out as a positive, and we get 2. So g of negative 1 is equal to 2. All right? So now sometimes it gets a little bit more complicated. What happens when there are multiple variables? Well, no matter what it is, in this parentheses, I'm going to plug it in every place I see an x. So f of negative 8 is equal to negative 8 squared minus 3 times negative 8. Now, technically, this is just a calculator question, right? I can plug that entire thing into my calculator and get a value for it, right? So negative 8 squared minus 3 times a minus 8, and you should get 88. Okay? So that helps. Another way that you can get a quick value for this is if you type the function into y equals and check the table, it should give you values for each one of these as well. All right, so that's another quick way to evaluate functions. However, that's not going to work when I have something like this, f of n to the second power. So what does this mean? This means, well, any place I see x, I'm going to replace it with n squared. So let's see what that looks like. F of n squared is equal to n squared, all raised to the second power, because the x is squared, minus 3 times n squared, giving me a final result of n to the fourth minus 3n squared. All right, so evaluating functions with both numbers and variables, it's all about plugging exactly what you see and not modifying the equation in any way. So another way they can ask you to evaluate functions is by looking at a graph, right? Like I said before, you can check the values of functions for particular values if you plug it into the y equals form, because the table will give you the values. So now the question is, what happens when they give you a graph? Well, remember, this is my x-axis. So anytime I'm looking for f of a particular x, I can look for it on this axis and find the place on my graph where this corresponds. For example, when the following values of the, find the following values of the function f of 6. That is asking me to find the y value when x is equal to 6. So we go over to 6 right here, and the point that we're looking at is right there. What is the corresponding y value? 2. So f of 6 is equal to 2. Let's try another. What is f of 2 asking? Well, it's asking me to find my y value where x is equal to 2. So that's right here. We go up to our picture, our graph, and we look for the corresponding y. That's 4. So f of 2 is equal to 4. What about f of 0? We're looking where x is equal to 0. That's right here on my y-axis. So I go up to where my graph is, and we get 7. And f of 5 is asking where x is equal to 5. Well, we're going to have to make an estimation here, okay? But we can estimate that's approximately halfway between 1 and 2, which is about 1.5, okay? So now I do have a question in reverse. What happens for a question like the one below? For which values of x is this statement true? F of x is equal to 1. Okay, what is this question asking? Well, it's asking me where f of x is equal to 1. Well, what is that on a graph? That's all the places where y is equal to 1. So if we take a look at this graph, what we are looking for are the x values that correspond to this place right here. All right, well, what do we get as our answer? Well, y is 1 at x is equal to 4. Where else is it equal to 1? Well, in this weird place right here that looks about, I don't know, 9.25 or 9.5. Both of those would be an acceptable answer. All right, so it does work in both ways. So it's important to differentiate between the inputs, which are our x value, and our outputs, which are